In this video, we're going to look at how we can easily convert hexadecimal into binary. Okay, so here I've got two hexadecimal numbers. Okay, so here I've got 40A at the top, and underneath that I've got 5B. Okay, now what I'm going to do is I'm going to very quickly show you how to easily convert them into binary. Now, if you've watched my video on converting binary into hexadecimal, you will hopefully remember, okay, that 4 binary digits. So if I write up 4 binary digits up here, okay, so I start at 0, 0, 0, 0, which of course is 0. And if I go all the way up to 1, 1, 1 is 15. Okay, so we can use 4 binary digits to represent 16 different values. Okay, we know hexadecimal is base 16, which means it has 16 different values, which means, very, very simply, each one of these symbols can be represented using 4 binary digits. Okay, so all I need to do is turn each one of these symbols into its binary equivalent. Okay, so just to revise again, hopefully you remember our numbers in hexadecimal. So we've got all the numbers from 0 to 9. Then we've got A, which is 10, B, which is 11, C, which is 12, D, which is 13, E, which is 14, and F, which is 15. Okay, so if we have a look over here, I'm going to start at the back, all right, just because, I don't know, I like to start at the back. All right, so we've got A first, so I'm going to turn A into its binary equivalent. So in 4 bits, so what you need to remember with 4 bits is, this one is the 1s, this is the 2s, this is the 4s, and this is the 8s. Okay, so we've got 1, 2, 4, and 8. Those are the powers of 2 that we've got. Always starting with the lowest on the right-hand side, remember. Okay, so A is 10, so I've got to make 10. So to make 10, I need an 8. I don't need a 4, I need a 2, and I don't need a 1. Okay, so there's A done. Then I've got 0. So 0 in 4 bits is just zeros, all zeros, there you go. All right, and now I've got to make 4. So if I want to make 4, okay, again, I'm going to use 1, 2, 4, and 8. So I don't need a 1, I don't need a 2, I do need a 4, okay, and I don't need an 8. There we go. All right, and so this here, okay, is the binary equivalent of this. Okay. Now, one thing I will just say is because, and you learn this in maths, don't you? We don't keep this leading 0, so we can take away that leading 0 there, and then that is the correct answer. Okay, so let's have another go with this one. All right, so we're going to do exactly the same thing with this one. All right, so we're going to start with B, which is 11. So I need to represent 11 in binary. Okay, so that would be an 8, no 4, a 2, and a 1. That's 11 in binary. Okay, now I've got to add a 5. So again, I'm going to, oops, sorry about that. All right, so I need a 1 to do that. Okay, I don't need a 2, I need a 4, and I don't need a 0. Okay, and I don't need an 8. I apologize for that, okay? And what I can then do is I can rub out that leading 0. Okay, and again, what I've done there is this. Oh, sorry about that, I'm still on the rubber. This is the binary representation of that. Okay, so that's very quickly how to convert hexadecimal into binary. Thanks for watching.